starting out this unit, I'm just creating a small little application here, index.html, app.js. I'm not going directly back into that MVC template because I just want to build out something really, really simple to explain essentially what is the main focus of this unit, and that is asynchronous code. You don't have to be in the MVC template to do this, and this is just something you can do wherever. So to kind of simplify at least this topic, we'll build out something very, very small just to demonstrate asynchronous code, and then probably in the next lesson, jump into a new application that actually utilizes some of this stuff. Typically, the way our JavaScript works, and we've been working with it for a while now, is it's going to run top to bottom as fast as possible, right? So I'm going to toss in some console logs in here, okay? Console log 1, 2, log 3, right? Oh, I got to host this actually. I forgot to do that. BCW live. And if I come back over here and refresh. Cool. So I have my console log 1, 2, 3. That's pretty typical, right? Nothing crazy there. But let's say that I actually wanted to have my code pause or have my code break and just delay a little bit, right? So what I could do is I could set a timeout. Timeouts can, delay the invocation of code by an amount of time. And let's just say that we wanted console log 2 to take a little bit longer. So we put 1 second right here, right? So we'll do it set timeout, and then after 1 second, it'll console log 2. So if we watch over here, we get 1, 3, and then 2, okay? So I was able to delay the invocation of 2, right, or the console log for 2, but you'll notice that as this code essentially ran, it console logged 1, it said, oh, wait a minute, delay the 2, run the 3, and then the delay happened, and then the 2 came afterwards, right? If I refresh this, we can kind of see that again. It's essentially reading this line right here, the console log, and is console logging 3 before console log 2 happens. So if I wanted to delay all of it, right, I would essentially have to move my timeout all the way down so that it would kind of do that. But that's not exactly the answer to everything, right? I only want to delay my 2, but I want the 3 to essentially still come afterwards, okay? So to do this, we do need to kind of introduce some functions, but this is where we can start introducing our asynchronous code here, okay? So I'm going to create a function, and I'm going to call it, I'll just call this start, okay? And let's put our console logs inside of there, okay? And then I can come over here, and honestly, this one's like so easy. Oops. Maybe I'll just come put a button on the page really fast. Button on click, start. Yeah, super tiny button there. Why not? Oh, we don't even have Bootstrap brought in here. We're going pure vanilla here. Style, font size, 24 pixels. Start, great. Padding, 10 pixels. Sweet, we got a great big old start button here. So we can just kind of run over here and do that, okay? So I'm moving my console logs into a function called start because there's something very special that I am going to do with this start that you essentially can't do by just running it in the JavaScript file, okay? But I'm actually going to create a new function as well, okay? I'm going to create a new function, we'll call this delay, okay? And let's just have the delay take in time. And essentially, we're going to move our console log for 2 into here. And let's actually take that time, do something like that, okay? And then we'll say delay that 1 second, okay? So now function start is going to console log 1, run delay, and then invoke console log 3. We should essentially get the exact same output where we get 1, 3, and 2, okay? But now we can introduce something pretty interesting, okay? One, I can run delay on its own, which is nice. And we'll see that I get that console log without, any time in there. If I pass in a different time, 500, that's great. This will be important in, a little bit, second here, okay? But this is kind of what I want to do, right? We don't want to have to continually delay things. We may not have a fixed amount for our delay. If we did math.random, maybe times, let's maybe do 4,000, okay? And we can go click our start button. So now we don't know exactly when it's going to happen, but we know that the delay is going to happen somewhere between, 0 seconds and 4 seconds. Oops, let's do a console log delayed by time divided by 1,000 seconds. So we'll kind of do that. Delayed by 0.05 seconds, something along those lines, right? So that tells us exactly how long that delay occurred. Sweet, very cool. I think that's totally fine. I think that's a good use case to do that. Something else that we can do, which is pretty cool, is you can actually create a console time delay and a console time end, and we'll do the same thing. Maybe we'll call this, let's do time and time. These just have to match. And this essentially gives us the time in between the first console log and the second console log, okay? So that essentially gives us a time between our 2 and our 1 and our 3. We can see this time that the 2 was delayed by 3.5 seconds. This console time tells us essentially how much time has passed from line 8 and line 10. This console time essentially tells us, or this log basically tells us how much time it should have been delayed by. Now we're going to see small differences in these numbers, but we want to try and make these numbers as equal as possible, right? We do not want to run into console log 3 until console log 2 has happened, okay? So how can we actually make it so that our code pauses and essentially waits for 2 to happen? And this is actually where we introduce a new class, or a new kind of very special class, okay? And this is called a promise, okay? A promise is a special class that essentially allows us to wait for certain things, okay? And depending on if, things work out or things don't work, we can actually stop the waiting of that promise, which is really, really nice. Think of the promise, though, quite literally. If I asked a friend, to go get me something, like, hey, friend, I'm, feeling a little hungry. Do you think you could go to the kitchen and grab me like a Rice Krispie treat? The friend is going to say something like, yeah, sure. And I now need to wait for them to come back and essentially give me that Rice Krispie treat, right? Or, I ask a friend to go get me a coffee or something along those lines. In all of these examples, I'm lazy and just sitting on my butt and asking people to go do things for me, right? But there is this waiting period that I essentially need to wait through until I get that coffee and then I can enjoy it, right? So that's kind of what our 1, 2, 3 is, right? 1 is I'm sitting at home. 2 is, hey, friend, go get me a coffee. 3, that's me enjoying the coffee, right? So I need those to come in order. And creating a promise or creating something that says, hold on, I'll be right back, so that our code can essentially wait for that promise to come back, okay? So the promise actually takes in a function that it will complete based on 2 parameters that this function has. resolve and reject. And we'll definitely get more into resolves and rejects in just a second. No, sorry, this needs to be new promise, okay? So we're actually gonna have like a couple different functions inside of each other, so I don't want that to get too confusing. I'm gonna try and space these out, okay? But essentially, I want to include this timeout in this promise inside of the promise. I want the timeout or this random to delay to be part of this promise here, okay? So essentially what this delay is now saying is, hey, when someone calls delay, the delay function is going to say, well, hold on, I'll be right back in just a second, okay? And to properly do this, we actually need to return this, okay? So that means the delay actually gives a promise, right? So if I actually hover over this, this now says that this is coming back with a promise. Delay is promising that something will come back, okay? And right away, nothing is going to change. We're still going to get 1, 3, and 2. Delayed by 0.11. Maybe we'll get a different delay there. Delayed by 2.5, okay? So nothing really happened because we're not really working with any of the promises features yet. A promise has been created, but essentially that promise is unfulfilled. If I actually were to, let's say, let promise equal the delay, and let's just include the promise right here. Oh, console time end. Sorry, you can't add multiple things to the console time end. Console log. What's a good promise emoji? How about we do the coffee? Let's do the hot coffee or the hot tea here, okay? Promise. Okay, we'll hit our start. We can see this promise, and it currently has a status of pending. It is currently saying, hey, I'll be right back. Currently, right now, the promise never comes back. So if the promise never comes back, we essentially can't wait for it yet, okay? And so this resolve and this reject is actually how the promise completes, or how we can essentially return with that coffee, right? And so we want to resolve this promise somewhere inside of our timeout, okay? If we resolve this promise right away, we'll see that if I start this, the promise is fulfilled immediately, okay? So that promise is immediately fulfilled by essentially just saying, hey, start the resolution, right? If I stick this resolve inside of my timeout, then along with these delayed console logs, the resolution of the promise is also delayed, okay? So the promise will take just a second, and then it will resolve. So our log says pending, but I bet you if I open this, the next time I'll see it, it is fulfilled, right? Because that popped up again. If I look at this one right away, it's still pending. If we wait that 2.6 seconds, this one might still say pending because I opened it, but we could potentially look at that promise again. And we would say that the promise has then been fulfilled afterwards, right? So that promise can be resolved after a specified amount of time, right? Kind of by our timeout here, okay? Here's where the magic happens. Our start function can now be tagged with the async keyword. We're essentially saying that this function is asynchronous, which basically means, hey, JavaScript, I know that you run, line by line as fast as possible. I'm just letting you know, at some point, you might actually not do that now. You might actually wait for something, okay? And just saying async doesn't necessarily fix everything. We actually have to pair async with another keyword here, okay? And that's right before my promise is created with delay, okay? I can actually now use the keyword await, okay? So now the way this console or this function start reads, log1, start the timer, wait for this promise, wait for this delay to happen, then end the timer, we'll log the coffee, and then we'll do number 3. So now that we have essentially used this combination, asynchronous and await, this code down here will actually respect the timeouts delay before moving on to 3. So we hit start, we'll see that it pauses at 1, 2, delayed by 1.65 something seconds, time 1,637. So again, right, there's gonna be tiny differences between these because a little bit of code does have to run. But we'll see those times are almost identical, right, between seconds and milliseconds. I guess I could get rid of this so that they really are seconds versus milliseconds. And it's just milliseconds versus milliseconds. So we'll see again that they are nearly exactly the same. But now my code is now running in order 1, 2, 3. 1, 2, 3. This is very important for when we are making network requests, because when I make a request to go get information, we don't know exactly how much time that is going to take. That could take a certain amount of time. So I found this huge image of some puffins, right? I think they're puffins. Puffin, yeah. Found this big image, this beautiful image on Unsplash of puffins. I have just the direct link to this image, like you could with index HTML and an image tag, right, with a source. You can paste that in, and then your website will effectively have that image. You can see that this image is massive. I'm specifically picking a very large image because I want it to take I kind of want it to take a little bit of time for that image to show up, okay? But just like you could bring an image into your HTML through an image tag, we can actually take URLs and actually have our JavaScript go and fetch that data. Now, I'm kind of using an image right now because that's a very easy kind of like concept here. Typically, though, you wouldn't be fetching images in this way, but it will help me kind of get across the point that I'm trying to make here, okay? So let's create a new function, and we'll call this get puffins, okay? Say let image URL equal this string. I'm just creating a variable for this so that I can paste this out really fast and we can kind of see what it looks like, okay? And this is going to be an asynchronous function, okay, because we are going to have some awaiting happening. And we're going to use essentially the built-in fetch method. This is something built into JavaScript, and something we'll see that it returns a promise, okay? And we're going to essentially say let image data equal that. This will actually give us back an image request. So we're not going to get anything too spectacular here, okay? And then we will log image data. This is actually not going to be image data. This is going to be an image response. We'll certainly kind of get into more about network responses and stuff as we begin to make more. Let's say fetch our image URL, okay? And I made it async right now. I don't have any awaits yet because I do kind of want to demonstrate something again here, okay? So if I come in here and I say get puffins and I send this code out, you'll see that I got essentially a log for promise pending, and eventually the promise was fulfilled. And somewhere inside this promise, we might actually find the data here, okay? If I go to my network tab, I probably want to disable cache just for these testing purposes, but I can also go to this other tab called fetch/XHR, and I can actually check specifically that one request that I just sent out, and I can see that I just made a request for that. So why don't we actually come back in here? I'm gonna make a new button. Get, is there a penguin emoji? Woo, look at that, beautiful. Get puffins, okay? It's a little bit bigger of a button, but who cares? So if I click this button, we'll see that that network request is fired off to go get that image. Okay, and we can see that it took 2.65 milliseconds to go and fetch that image. So again, pretty quick, certainly much longer than whatever my kind of random time was up here. But you don't know, right? Maybe I'm on very fast internet. Maybe this user's on a phone or something along those lines. That network request is not predictable. If I fire off this GET request again, it actually took a little bit more time, right? I can do it again. 272, 258. So it's certainly fitting into a particular range, but it is taking, a bit of time to actually get this image to show up. We can see that even though the time is, falling within a range and it is somewhat predictable, it is a different time every single time. And we don't actually know what that time is until after the information came back, right? Here we kind of knew what the time was going to be right before the delay since we kind of created the time. But because this time does change basically every single time, you can see how if we just created some sort of timeout, it wouldn't really work. We actually need our code to pause and wait for this information to come back. So we can come back to our console here. We can see all these different promises popping up. We can just kind of clear that. And let's actually await this fetch now. We will see that this image response is no longer going to be that promise pending that pops up. This should be an actual response from going and getting that image. Again, it's happening pretty fast. Okay, but these are kind of what network response looks like. If I look into the network tab and I actually look at a lot of this information, this was a fetch request, status 200. That just means 200, okay, you got the thing back. Gives me kind of the size and the time it took to take. And if I kind of click on this, we'll see that we actually got certain amounts of information back, things along those lines. A lot of that is actually represented here within this console log 2, including this body, this readable stream. We're not going to worry too much about that and kind of like this image. We're essentially just going to stringify this image and just look at what an image might look like as a string, as data. It'll be kind of funny, but we can see that this actually waited now. Maybe I should have picked an even bigger image that took like half a second because this is so fast. Unsplash, I guess, probably has lots of stuff to make sure that their images are coming in at great resolutions here. Let's see if I can actually trick it. Can I do width? If I make this like a 4K width, will it come in 4K and will this take a hot minute to load? Maybe. Let's try this again. Let's, Unsplash's API does have some pretty cool stuff. Let's see, ooh, 7.3, 7 mega. Oh, dang it. Is it still caching that image? I think it's still caching that image because that first time it took 1.74 seconds. I bet this is Unsplash. Unsplash is probably caching that image and making it super fast, but that first time for me. So, can I actually trick Unsplash? Let rand width equal math dot round math dot random times 4,000. Actually, let's do 3,000 plus 1,000. And then plus random width to the end of that. 1.2 seconds. 1.3 seconds. I tricked it. I was able to trick it to think that I'm asking for a different image each time. So I'm probably going to undo all that. I am essentially able to wait for this response to come back. We can, just for fun though, say like let image data equal await image response. We could turn it into all these things. I'm just going to turn it into text. And then we can log the image data. And we should get essentially the data of the image as a string. There's certainly better ways to stringify this image data. Show 258 kilobytes more. There's more image data here, right? This is not obviously typical or really useful for anything that we would want to do with it, but it is kind of fun. It's kind of funny to kind of look at all of that stuff. There is some things in here that you can kind of see, which is interesting, kind of baked into this. It'd probably be better to try and convert this into a different type and not just a string, but it is kind of interesting that you essentially can do that. You can kind of convert all these things, okay? But those are things that take time, right? And we essentially need our code to be able to pause when it reaches those lines, because those are things that take time, and we don't know how much time it'll take, right? And so we essentially need to pause the code before we continue. If we don't pause, we're essentially running our code lightning fast, and we're never waiting for a lot of these things to come back. And you might be like, well, of course I don't want to pause. I want my code to come back lightning fast as possible. I promise. Most of this stuff is extremely, extremely quick. But we can't get around the fact that we do need to integrate different network requests at different times to retrieve, potentially valuable information from, a database or images or something along those lines. But cool. I hope this was kind of a cool little demonstration of promises. We typically won't create tons of promises this way in our code. This is something that is a bit more typical, is that we're utilizing functions that already use the promise system, like fetch. Fetch just takes in an image URL and essentially goes and gets something. So yeah, cool.